Hi, and welcome back to Coking.com. And I'm here with Chuck Munro of Spray Systems. As you can tell, we are on the shop floor at Spray Systems here in Houston. And Chuck is going to give us a little briefing on the different types of spray nozzles they make and why you would choose them in different circumstances, and talk a little bit how they plug and how they foul. That would never happen in delayed coking.
Never.
So Chuck, please tell us a little bit about these nozzles.
Well, there's different types of spray nozzles have different spray patterns and different uses. This is what's called a full cone spray nozzle. And you can see on the inside of this spray nozzle, there's a vein inside there. And that vein is stationary, and it helps when the liquid comes through, helps it to form the spray pattern.
Okay.
One of the things about the full cone nozzle is that this is the limiting factor as far as free passage.
Okay.
So when we talk about free passage, we're talking about the ability of a spray nozzle to flow a certain solid particle through.
Mm-hmm.
And you mentioned pluggage, and pluggage can come from different ways. It can come from solid particles that can't flow through by itself, and it can come from buildup inside. So maybe you have some mineral deposits that build up over time, and then that can help to reduce the amount of free passage.
Mm-hmm.
And also pluggage can come from the outside.
Sure, I've seen that before.
Exactly, yeah. So anyway, the full cone nozzle, the limiting factor is here on the inside, and it will give you a full cone spray pattern. So it's a very round full cone.
Yeah.
Yep.
So if you can imagine like a splatter picture, it would be 100% dots on the tip.
That's absolutely right.
And in our unit, in the delayed coker, we would normally specify a strainer upstream of this that has a hole size which is smaller than this free passage. Yeah. So how do you select what hole size should be?
Well, from our perspective, as a general rule of thumb, we go 1/4 of the maximum free passage. So 25% of whatever that maximum free passage is. In any spray catalog, you're going to see it should list what that maximum free passage is.
Yeah, sure.
Or if it doesn't actually say maximum free passage, you just use the smaller number that's listed, and that's going to end up being your free passage.
So if this had a free passage of, 10 millimeters,
right,
you would go with 2.5 millimeters as the target.
That is
strainer size.
That is correct.
But yet with that, we still see fouling.
Yeah.
Right.
Yeah. And I think it sometimes comes with, like, if you have particles or matter that is able to flow through your strainer, it could build up over time inside the spray nozzle. And the only way around that is to use a bigger spray nozzle or a larger free passage. But then you're dealing with flow versus pressure scenarios that you have to understand.
And you change the droplet size, you change the dynamics of the entire system. So there's really pros and cons to be said. So we've showcased this one. This is a full cone. And so what's this little pigtail little guy?
Well, colloquially around the industry, it's called pigtail. But this is it's a spiral. Looks kind of like a little corkscrew here. Mm-hmm. And most people think that this spray nozzle right here actually has maximum free passage. And when you start to get in the larger sizes, most full cone nozzles actually have larger free passage than this.
Okay.
And
it's a little counterintuitive.
It is very counterintuitive, but a lot of people believe that. And one of the way that this works is when the liquid comes in, it shears off of these individual veins. Mm-hmm. So you actually have cones inside of a cone. So if you look at this spraying against this, go into your little pixel argument here, mm-hmm. this one would be much less even. It would be lots of rings.
Little rings. And I think in a separate video, we're going to showcase your little test rig over there where they actually, have a little live demo. Yeah. You can see these spray patterns and really get a first-hand understanding of how that actually looks.
Yeah, I think it's important for people to understand not only in what they do, but actually to see what they do, to see the differences and everything.
Yeah, it really drives the point more clearly. So this is a spiral flow pattern. So we got the spiral, the full cone, and our last but certainly not least one that I think is one of the best choices in the delayed coker fractionator for wash zone. This is a hollow cone design. So we want to give us the rundown on how this works?
Sure, absolutely. So the first thing you'll notice, I'm not sure if you can pick this up on the video, but the first thing you'll notice that there's no vein inside of here.
Yeah, it's just totally empty.
So if you look at this nozzle versus this nozzle, same flow rate, same pressure drop, this one is going to have much greater free passage because there's no vein inside of here. One of the things to understand about the hollow cone spray nozzle is that when the liquid enters this whirl chamber, it spins, and that spinning causes this centrifugal force, and then the liquid exits off of this formed orifice. There's actually an air core that forms in here, and then you get a round hollow cone spray pattern.
And it's like a curtain of liquid coming out.
Absolutely.
So like one of the reasons why, just from a cocoa process guy's perspective, I like this nozzle is because it creates kind of like a curtain of liquid that the vapor has to pass through. And it has a better washing effect. We're not going for mass transfer here. We're going for washing, right? So forcing the liquid or forcing the vapor through a curtain of liquid, to me, seems to make better sense.
And to go along with that, this particular spray nozzle, as compared to the full cone spray nozzle, will have a tighter drop size distribution. So the drops are more similar in nature. And so you also get smaller droplets in general, which gives you more surface area for that scrubbing.
Interesting. Well, thank you for the rundown of the 3 different nozzles here that Spray Systems offered. I feel like I learned a little bit about free passage. So thank you, Mr. Munro. And if you'd like to learn more from our friends at Spray Systems, feel free to join them at the conference RefCon. They're going to be there as a presenter and an exhibitor. So thank you for your time. Very much appreciate it. Thank you.
You're welcome. Thank you, Evan.